Good morning.
Morning.
My name is Shobha, Subramonian, and I'm a program manager at SAS here in Cary. And I am managing the Customer Intelligence 360 program. I'm here today to share some insights from a journey that we took to make the transition from a traditional on-premise type delivery model to a cloud-based delivery model, from a once-a-year release delivery model to a continuous release delivery model. This transition was needed because we had decided to launch a new product offering, a digital marketing product, which was cloud-based and which would be set in a multi-tenant environment. So in today's world, there are many products that are becoming more and more available in the cloud as more customers gravitate towards these types of products for the various benefits that such cloud-based products have to offer. Low or non-existent cost of infrastructure, always being on the latest release, don't have to worry about upgrades to the next version, things like that. One of the benefits of continuous release is also that you can get features to the customers very quickly. The continuous release process allows us to get feedback from the customer and incorporate it into the next release very quickly. So this feedback loop, get feedback from the customer and then incorporate it into the product and quickly put it into the next release, roll it out to the customer. This is something that is very beneficial from a customer perspective. So we are still on this journey. We're not at the end of it, but we've made long strides to get towards the goal that we wanted to achieve. So I'll share some of our experiences as we started out on this journey. And I also want to talk about how we scaled to fit the program. We have a large program, and I'll share some insights from that as well to keep in keeping with today's theme of scaling culture. So this is a case study, basically our organization's journey of moving to the continuous delivery model and how we made the transition and sharing some practices that might work for others. Here are the topics we're going to look at: where we were when we started, what our new destination was, the challenges we experienced, what our transition plan was, the hybrid approach that we started our journey, rocky road that we encountered, the mindset shift that was needed to make this transition, what is our current code delivery model, where we're now, where we want to get to, a look at DevOps, which is a very intrinsic piece, part of the continuous delivery model, and a focus on our scaling culture as well. Where we were, so we used to do on-premise deployments, and we still have products, many products, where we still follow that model. Our releases were once a year if you counted the maintenance releases, otherwise it's probably like once in 18 months or once in 2 years. Long development cycle. We did use Agile. We were using 4-week Agile sprints, and theoretically you're supposed to be production ready at the end of every Agile sprint. But there's a big difference between being theoretically ready and actually being production ready. As we figured out when we went to the continuous delivery model, when you're required to be production ready. I also want to add, as I go through the presentation, if you have questions, please feel free to stop me. I have a number of slides to get through, but if we get tight on the time, I'll let you know. But otherwise, I welcome your questions. So this is just a pictorial representation of our development cycle. We would start with a few weeks of release planning and scoping at the start of the development cycle, and then have a series of iterations where we actually built and tested the code, several Agile iterations, probably ending with a couple of stabilization iterations, and then getting ready to package, release, and ship the product. What was our new destination? We wanted to be on a hosted environment, and we were going to use Amazon Web Services for this. We would be on a multi-tenant environment with a single code base for all the customers. having a very short development cycle. So basically, every sprint, we wanted to do a new release. And our sprints were 4 weeks long. So basically, we end up doing a new release every 4 weeks. That was our goal. This is what our new setup would look like. We'd have a common application layer with our operating system, our source code, hardware, etc. The customer's data is also hosted there, separated in their own databases, but that is all hosted on the cloud. And each customer is able to access that solution through the URL that is provided to them and go directly to the hosted solution. And this would be what our development cycle would look like now for our very short continuous release model. This is pretty much one sprint. This is just one sprint, and our release was to be ready at the end of that one sprint. We would plan a set of features that would fit in that sprint, and then work on that and get it ready. And before the sprint started, we would spend a few days to scope out what it is that we would actually be working on in that sprint. And as we were wrapping up the current one, we would start the next release. And the planning for the next release is going on while we are working on wrapping up the current release, and so on. And this becomes our continuous delivery model. Typically, the key to continuous delivery or continuous release is automation. Lots of automation. Automation of the entire delivery pipeline or deployment pipeline. But automation requires time to build up. It is not a quick and easy exercise. It takes months and years to build up a fully automated delivery pipeline. What are the types of automation that we needed? So in our continuous delivery pipeline, it is possible to automate almost every activity, every task in the process of delivering code. Other than actual creation of the code, you need the developers to be actually building the code. But after that, you can automate unit tests, you can automate end-to-end testing, functional tests. You can build automation to build automatically as soon as you merge code. You merge code into, let's say, the master branch, and we can have automation to detect new code has been merged in, and it should trigger a build. Or you might have automation set to just start a build maybe a couple times a day or 3 times a day, something like that. Once the build passes, then you automatically deploy. You detect that the build has passed and then deploy it onto your stack where you want the software to be deployed. Once the deployment is done, again based on the success code from that deployment, you can say, run this series of health checks to make sure that the solution comes up by itself. And all these parts, these key parts of the application are working. Ping these services and make sure that this is all working. And so that can be automated as well. Once that is automated, the whole solution, basically you have built, deployed, run validation checks or health checks, and that part has been automated. Once that is done, you can say, okay, now if this all passes, promote it automatically to the next stage. Get it to our pre-production environment. Run the same deployment and tests there. Maybe you have a more enhanced set of tests go before you get to production. And then once that is done, you could theoretically even promote automatically to production. Most companies will probably do that as a manual step. You want to have the control of saying, okay, you're doing this release at this time, and this comes with this set of features. But it is possible to automate most of that delivery pipeline. And that is a truly continuous delivery pipeline is usually automated, but in most cases, many cases, some parts of this pipeline do require manual intervention. So that automation, building up the automation was one of our biggest challenges. right? That is a big task for us to accomplish before we can have a fully automated pipeline. We also had other challenges. This was new technology. We were learning about Amazon infrastructure services, platform services, and to design the architecture for this new infrastructure, design what instances we would have, what were the different environments, the different tiers, how code would flow through these different tiers, how it would get to production, and so on. So a lot for us to learn, and these were the challenges that we encountered on the way as we started this new journey. This is a slide from Amazon, and it's a very good comparison of the old and the new. You can see for all of these areas what the equivalent services are on the Amazon Web Services now versus what we used to use before. Servers, for instance, we had the on-premise servers before, and now you have EC2 instances, the elastic cloud computing from Amazon. For networking, we had routers and switches before, and now we have the elastic load balancers, the virtual and private cloud. So it's just a comparison of the great difference in technology between what we used for the on-premise deployments versus what we use in the cloud deployments. So what was our transition plan to get to having this new solution in the cloud? We were going to do it in two phases. First, we were going to build an early version or a beta version of our product and put that first version out there in the cloud. And we would run it almost like a traditional on-premise type deployment with that long development cycle. We were going to plan it like that. So we allocated about 10 months for it, and we finished it roughly in that time. I think we took maybe about 11 months. And we did have, at the end of that phase, an operational working software in the cloud. And we had 2 early adopter customers, so people who were willing to look at that software, wanted to work with that software, and give us feedback on how that worked. Then, once we had that basic software in the cloud, we were then going to make the transition to continuous delivery. And at the same time, we would be bringing on additional customers, and we had to move into a full production mode from this beta mode that we were in. And for that, we arrived at a hybrid approach. We would have a release every 4 weeks. So this is the approach that we came up with for our organization to make the transition and for us to get to a continuous delivery mode. This is the approach that we came up with. We would have a release every 4 weeks. It will follow a 3-sprint cycle. There will be 3 phases. And the 3 phases were development and test, which we call dev test, and then integration phase, and then finally a release candidate phase, where we would actually finalize the release and then deploy it in production. And over time, we would reduce the length of this cycle. And let me show you what that looks like. So this has a bunch of detail in these phases, but basically what I want you to look at is the three sprints that we took for every release. So the first release would come at the end of the 3rd sprint, but after that we would have a release every 4 weeks because we would be layering the work on top of each other like this. Most of the work is done in the dev test phase. For every release, about 80% of the work happens in the dev test phase. This is where the code is actually built and tested. Product managers validate it, and they sign off on it. They accept the stories, and the code is then ready and merged into our master branch. After that, we run some integration testing, some end-to-end testing on that. We have translations and things that happen on that. And then finally, we deploy in production. Bless you. And the reason that we had this time was because we didn't have automated processes to run all that testing that would normally run in a much shorter period of time. This was all fully manual for us still. So this allowed us to begin to get into a continuous delivery model, but our intent was that over time we would shrink this time period and get into something much closer to one sprint, which is where we do the bulk of the work, which is building the software. So the dev test phase, majority of work done there. Cut over to integration. There's only a small subset of our large team that's focused on the integration phase. Once we cut over to release candidate, an even smaller team where they do the final validation checks, do the operations readiness, and then it is actually deployed to production. So that was our plan as we started out. We were going to do the first continuous release. We were going to deploy that in September and put out a release every 4 weeks after that. That was our plan. We had 11 teams at that time. Our program has grown to about 15 teams now. Every team had about 8 to 10 members, 6 to 12. We had 4 project managers, and we still do across the whole program. So it was a large program. We had set standards across the program for our sprint process, story templates, acceptance criteria, various. So we had consistent guidelines across all the teams for everyone to follow the same thing. So we had a plan in place to start executing on. You may have seen this before. Many teams, or most teams, when they form, they go through these cycles really to get to maturity. And our teams had come together basically only a few months before when we started work on that beta release. That's when many of the members came into the team. They came from other teams. They came from sometimes non-agile backgrounds. So there was definitely this norming activities happening while we were maturing and getting into a rhythm of working together and working well as a team. So our first continuous release did not come in September as planned, or in October. Found that our scope was too large for the sprint, that first release that we had planned. And we could not complete the testing. So we continued to work on it, and we finally released it in December, 3 months beyond plan. So this was a shift that we required to adapt to. We were used to planning for long development cycles, and this was one of the big challenges as we moved to the continuous delivery model, where you had to really shrink what you planned for into a short sprint, 4-week sprint, and really make it release ready in that time. So we held retrospectives to see what should we do better so that the next release can come out on time and we don't take 3 months for the next release. And we realized very quickly that the scope that we had planned was too much. We slashed that, minimized dependencies between teams. So we have several teams. 3 of our teams are in India, and we have team members in the UK and some other remote locations. The majority of our teams are in Cary. But we, again, needed to find efficient ways to work together so that a story is not held up because of a dependency on another team, or a story that is to be delivered by another team, an interface that is waiting on, or some input or feedback that is waiting on from a component that is being built by another team. So we have to become more efficient in our planning and find ways to align our plans so that we would all be timed in a way that we're all converging at the same time. And these are all tasks that become more and more important as we plan for the continuous release model, where we really need to be putting out a new release every month. This is our timeline from 2016. We missed 4 out of 14 planned releases. while we were making that transition, this was one of the challenges that we were getting into. We planned work that we couldn't finish, then we were, if you missed that cutoff date for getting your release done, then you begin to trample on the next sprint, and then you're butting up against the next cycle, and it's not easy to recover from that. So basically, the only way to recover is basically you combine two releases and release it as one, which is why we missed some of those. And you can see earlier we were getting some delays with our releases as well. But towards the end of the year, we began to get better with this, and we had a few releases on time. And this was our timeline for 2017. You can see we were much better. We only missed one out of 12 planned releases. We decided not to do December releases anymore with all the vacations and things. Challenging to put out a release in December. So we don't plan for a release in December anymore, but we have 12 releases a year, and in 2017 we missed only one. We were a couple weeks late with one of them, but most of them were on time. And I'm happy to say in 2018, we have not missed any release. We have put out 10 releases so far. We're on our way with the 11th one. And we were 1 week late with one of the releases so far, but everything else was on time to the day. Mindset shift. Meet the need to get new features to customers quickly. One of the benefits of continuous release or the continuous delivery model is that it enables us to react to customer feedback very quickly. You put this software out on the cloud, it's immediately available to the customer. They don't have to upgrade or anything. They're immediately on the latest version of the software that you've deployed on the cloud. Anybody who's got a tenant on your cloud immediately has that software, and they can see the new features. They can provide you feedback, and they can tell you, is it in line with what they're expecting? What is the next thing they'd like to see? What is the next highest value-added item for them? You get quick feedback. And we have the ability to take that feedback and quickly adjust our plans so that the next set of items that we're putting out is aligned to what the customers are seeing. This is something that we really needed to get our minds around and make sure that we were not building features out to the nth degree before we put them out in front of the customers. That we have an idea, you start building it out, show the customers an early version of it, get their feedback, and build it with their feedback. And then you arrive at a much more efficient solution and much more targeted solution aligned with what the customer is expecting than what you would have if you were to do it just by yourself, as we used to do before with our long development cycle. So deliver the basic functionality first, do all the additions and embellishments afterwards. Show them an early version. See that you're on track. And if you need to adjust your where you're heading, that's easy to do when you start with an early version. You want to chunk up the stories so that they are deliverable within the sprint. Don't plan stories so big that it takes 2 or 3 sprints to finish. Do it so that you can finish little pieces of it in a sprint, in a release, show it to the customer early, and then build on it. So these were some shifts in our mindset that we had to get adjusted to, and these are benefits that come with the continuous release that we really needed to embrace. Yes?
So during this almost 3-year history, have there been cases of more fundamental architectural changes that really challenged that, ability to chunk up these architectural changes in stories so that they fit them up?
Yes. So the question is, were there architectural changes that challenged this ability to chunk up the stories? The answer is yes. We do have what I'll call some platform changes and things like that, which challenge that ability. But I would say the bigger challenge for us was just coming from the mindset that we had before that we build something out to and finish it. We have this mindset that you've got to finish something, put a bow on it, and then hand it off. So we want to take it almost to a degree where we feel, that the developer feels that they have built it out fully, or the UX designer has given a design which has got a lot of detail, right? But it's done with initial feedback from the customer, and when the customer actually sees it, they give us feedback which is even more valuable for us to actually help finalize what that feature should look like. So I would say that is the bigger challenge for us, to just get into the mindset of thinking that we don't need to finish building out a feature to the customer.
But does that mean that the more significant architectural changes simply were bumped up, and customer might not have seen them?
That is true.
But you had to break the developer's mindset that said it's okay to put in, if you would, 1/10 of the architectural change on this release, and you'll just keep adding to it, and eventually you'll start to see its functionality.
Right, and I think I understand the point of your question a little better now. The architectural changes, I would say, fall in a slightly different category because they may not be transparent, right? What we're doing, it's only the functionality that the customer cares about. So we do have changes that will take more than a sprint to finish, and especially changes related to architectural changes and some other changes that maybe you're building up a certain enabling feature to create a runway for features that can live in a certain space, creating a framework and things like that. Those things will very likely take more than a sprint. But that's okay. We chunk it up in a way so that it is still deliverable within a sprint, but this is not customer facing, right? Those are not customer facing. Right. So those are less critical in that respect, but less critical to the way we chunk it up. You can chunk it up as you wish, but for feature functionality, it makes sense that we should deliver pieces of the functionality which can be presented to the customer. Does that make sense?
Yeah, thank you.
Mm-hmm. Yes.
So, as you mentioned that you had 2 customers who were forward-thinking that came on board, gave you feedback.
Yes.
In the past, you had yearly releases. So sort of expectations were set that any new features you're asking for will be delivered a year later. Mm-hmm. But now that you're on a frequent release, what do you see in expectations also rising?
That's true. So as soon as the customer gets on the cloud environment, right, and they know that the next release is going to come in a month, the next release is coming in a month or 2 months, their expectations are immediately set that you can ask for some changes and you will get it much sooner than the next release that would have come the next year or the year after in a previous or in our traditional models.
Help me locate where it is. So from the moment they request something from Microsoft, the lead time to it, mm-hmm. and all the new requests that are coming in because you've changed it. Mm-hmm. Where are you in kind of blowing up, or is it in control? Where are you in the spectrum?
It is I think the question, if I were to understand you correctly, is how can we predict at what time or when in our timeline we're able to deliver back to the customer the feature that they're asking for? Or is our list constantly growing because
you're building faster, right? Which is awesome. You're taking the right steps. You're getting better at continuous delivery. And are you building the right thing? Mm-hmm. And yes. How is this continuous discovery fitting in?
That's correct. Are we building the right thing? That is a key question that we want to be able to answer with a yes, and that allows us, the continuous delivery actually puts us in a better position to be able to do that. When we get the customer feedback for new features or enhanced features or improvements or whatever, that goes into our priority list. And it may shift other priorities based on what the requirement is, based on what the importance of it is to the customer. So we have a priority list of features that is maintained by product management, and that is the list that we work off of for deciding what is the next set of features we work on. And when we get feedback from customers, it can get anywhere in that priority list based on the importance of it as determined by product management and the customer. Yes.
So do you have a two-part question? So one, how do you communicate? If you have any customers that have changed process, data integration, them a heads up. How does that affect you?
Okay. I don't think that the customers who are on the cloud environment have an expectation that they are going to get changes on a frequent basis, and they look forward to that because they have requested improvements and they have the ability.
What are they getting?
Yes, they do get release notes from us, and those are published before every release, and those are made available to the customers before every release so that they have the set of features that are going to be available with the new release.
So they know what's coming, but do they actually expect you to link the change?
To link into their change management.
Yeah. We actually do, and I think it's a little weird, but we actually have a lot of software. But we have our own identity access management. Right integration out of our system. Not all of it. The change is coming that impacts our warehouse, our data. Heads up, so we can figure out how to.
Okay.
Because it's a weird mix of software as a service, but then there's the whole data integration. Why not?
Mm-hmm.
So actually, we do have a mix of that. We have some cloud solutions that are highly configurable.
Yes.
That we do have to do some change management around. With some of our vendors, we have testing windows where we can go in sometimes on minor releases they would put off for us. But it just, it's not one size fits all anymore.
Yeah, I'm thinking it really would slow DevOps down, especially if you got a bunch of customers asking for it. I'm just curious to see if anybody had.
So, I think I'm not recalling that we had a major issue with that particular topic or that particular question. We haven't had a customer say, no, you cannot put this change out because we're not ready to, we haven't. And normally our features that we put out is because it has come from a certain number of customers, right? So it is very likely that other customers generally want that. And we have not had any major issues with customers with refusing or not wanting to. And of course, we do have configurations for every customer. The configurations are set differently, so every customer's tenant may not look exactly the same.
On the customer, customers know what they're signing up for.
Yes.
I mean, we know that.
Yes.
We sign up for something that's a cloud solution. We know this is our front room.
That's correct.
And we also have to conform to that.
That's correct. Yes. The customers have that expectation. It's part of being on the cloud that you have that.
These early adopters, what percentage of all your customers are these early?
Those are our early adopters at that point in time. They have since converted to being a regular customer. So while we were on that beta version before we went to production, they were actually early adopters. And then we have had customers where they will be in sort of in that early adopter mode for 3 or 4 months, kind of trying out the software before they actually become a full production customer. So we've had that, and percentage-wise, I don't know, less than 5-10%, somewhere in that range. But it's not that they're not early adopters forever, right? I mean, it's for a certain period of time, and then they become a full customer.
So your bulk of your customers still are not.
Oh, for this, so this is a totally new offering, right? So this is a separate offering. For this offering, we have a number of customers now on the cloud platform, but they are all using just only the cloud version. Okay. That first seems to have stopped working. Is it stuck? Okay, there we go. Delivery model. So we experimented with a few different types of build processes. I won't go into much detail about that. I'll show you the model that we have now, that we've arrived at. We actually have a monolith code base. Our entire code for that software is in one big monolith, but we are working now to separate it out, to break it out into microservices. We have a code coverage target of 80%. This is our target that we strive to achieve. We are close to that, and a few teams are beyond that, but many are still getting there. Sprint completion target of 80%, which means that we want to complete 80% of the stories that we accept or plan for that sprint. And our defect rate, that measures to make sure that we have quality control and that we have weekly and monthly reports to track all that. All right, so this is a look at our code delivery model. We have a master branch, and I have 3 sprints laid out here, sprint 1, 2, 3. And this is just to show you how our model works. So let's say we have 3 features planned in the first sprint, features A, B, and C. And they are feature branches created off of master, and the code is being worked on, the developers work on those branches. When features are completed, they get merged back to the master branch. So this is, let's say, features A and B get completed in the sprint, they get merged into master. And feature C is not completed, and therefore that story moves to the next sprint and to be worked on in the next sprint. And that happens at the end of that sprint 1. And at the end of the sprint, what also happens is that we spin off a release branch from our master branch. So that becomes our release 01. Let's call it release 01. For sprint 01, we have now spun off or cut the release branch from master, and that becomes our release branch. In sprint 2, this release branch is going to get deployed in our integration environment, and that goes through integration testing and all the other work that is planned in the integration phase. And in the meantime, features are now beginning to get worked on for sprint 2 by the developers. Features C, D, E are being worked on in sprint 2. At the end of that sprint 2, this moves into our release candidate phase, and at the end of sprint 3, it gets deployed to production. So this is our 3 sprint cycle. So this is what our current delivery model looks like.
So if you have release, if you go back to that slide, so say feature A is after it moved to integration.
So, good question. So if there's an issue with feature A, does it move back? Can it be rolled back? We don't roll it back. We just fix it. So it's a fixed forward type of delivery model. So whatever issue it is, we've got to fix it.
Fix it in those. So it's still fixed.
Yes. So only defect fixes are allowed once a release branch has been cut. We don't add any new functionality, no new stories, no improvements or anything like that. The only thing that is allowed into that release branch is defect fixes. Developers push code to feature branches. When ready to merge, they send a request to merge contacts. So we have a controlled process to get into our master branch. We used to have it open to everybody, and then we found it was breaking all the time, and we just couldn't get it stable. So as I said, we experimented with various different processes, allowing people at different time slots and all this kind of stuff. But this is what we arrived at. We have a few people who will merge to a master. Merging into integration requires a higher level of care and approval. So it needs approval from our manager, either a tech manager or a dev manager. Merging into a release candidate, once it's gone into that last phase, it requires even more care. So it requires approval from either a director. It requires director level approval. And typically it's only no shift defects that we would allow at that point in time. Yes?
It does seem like there has to be arrows going the other way to get those changes back into your master.
That is correct. That is correct, yes. Whatever change goes into RC has to be retrofitted back to integration branch, and so every branch that comes after that. So you may discover something here, and that fix would need to go back to this branch and the master branch. If you discover something here, that fix would need to go into here and the master branch. This is where we are now. This is our timeline, and we are now delivering reliably every 4 weeks. We achieve 80% and more than 80% of the plan scope delivery. But overall, across the program, there's a few teams that will still get below that, every now and then. But in general, we are able to hit this target. Where we want to get to. The ability to deploy once a day in production automatically. This is especially useful for defect fixes. You want to push something quickly to production. We want to be able to do that. We want to deploy without downtime or outage. We do have a short outage now. We are able to finish production deployments in about 3-4 hours per region, but there is a little bit of an outage to at least certain components. And we would like to try to do it without that. Complete releases closer to one sprint. And the 3-sprint model was just for us to get over that initial hurdle of not having all the automation that we need to build up our pipeline. Once we have all that in place, we hope to bring it back much closer to the 1 sprint. Deploy a component versus a monolith. So we are, as I mentioned earlier, we're beginning to break down our code into the different microservices, and we would like to be able to just push one microservice to production instead of the whole thing. That requires automation of the whole pipeline, and the more you can automate, the more efficient we can become with our process. DevOps. DevOps is a very important part of our pipeline, the DevOps philosophy. Basically, DevOps is the close collaboration between development and operations, so that we arrive at a more efficient process of delivery of code to the customer, delivery of functionality to the customer. It makes the process much more efficient when there's close collaboration between development and operations. Again, in our old traditional model, we had development. In the first majority of the phase of the development cycle, it's just the development groups and the developers and development teams that are engaged. And then ops comes in at the sort of very end to figure out what needs to be deployed, what is required for the deployment and so on. But in the continuous release model, we try to have a very close collaboration between dev and ops. And this helps our deployments go smoother, and for developers to learn what it is that they have to build into their software to help that deployment go smooth. So it's a two-way feedback system to developers. Developers build, test, release. They are sending software in the delivery pipeline. Ops then deploys that and puts that in front of the customers. And the ops can monitor the operation side of it. They also monitor the deployment and will have feedback from the deployment itself. How did the deployment go? What were the issues they ran into? What could have been done better to get the deployment smoother? What is happening now in production with the operations that could be avoided if we put certain checks and alarms or monitoring systems, or maybe other types of feedback from the customer that would make the product better and the deployments better, the operation of it better. So the feedback goes both ways, and right now we have a very good collaboration between development and operations. We have a checklist that our ops team produces that has to be filled out by the development managers in the middle of our dev phase, that first dev test phase, to say, there's a list of questions or their impacts for this, that, and the other, and that checklist, that information that we provide, that the development managers provide, helps the ops team to figure out what the impacts may be that they would have to keep in mind as they deploy, and then they are able to have a smoother deployment because of that. So that becomes a very key piece, especially because we deploy so often, right? It's not once in 2 years that we deploy the software. Now our deployment is a very frequently occurring activity, and therefore we need to get efficient with our deployments. All right, scaling culture. So we have a large program. We have 15 teams, with 3 of them in India. We have, I think, about 108 or something like that developers, maybe 46, 45 testers somewhere around there, 10 product managers, and 4 project managers, of which I'm one. So I'm the program manager with oversight for the whole program, and then we also have 3 project managers, and the 4 of us have managed the program, manage all the teams for the program. How do we ensure that the whole program is pulling in the same direction, and that our practices are scaling across the entire organization, that we are consistent with all the teams, that all the teams are building pieces that will eventually come and converge at that release point, right? All the pieces that you're building separately, all these teams are building their pieces separately. Everything has to come together at our release date. They all have to work together. How do we do that? So we need to have these practices and all these guidelines in place so that we can have an efficient process so that it actually happens, that they all come together. Our scaling methodology is homegrown. It was not designed from SAFe, which is the Scaled Agile Framework. We started our methodology about 3-4 years ago, more than 4 years ago, actually. So, but it doesn't actually align with some of the concepts from SAFe, and some of you may be familiar with the Scaled Agile Framework. Their methodology. They have the release trains and the program increments that they prescribe, the methodology which we do, certain how we lay out our plans and our releases, etc. But the high-level concepts that alignment is required, alignment to schedule, alignment to a common delivery model, alignment to a common process. This is universal, and this is needed in a program which is as large as the one we have, and in any large program, it's required to have alignment with all these things so that we can have an efficient process and be able to deliver our product efficiently and successfully. We'll delve into each of that just a little more. Alignment to a common schedule. All teams have 4-week sprints. At the very start, close to the start of our program, we made the changes so that it's not just that they have 4-week sprints. They actually start and end on the same day. They actually have the same sprint in Jira. I'm assuming you're all familiar with Jira. So in Jira, we actually have the same sprint that all 15 teams use. So the 15 teams have 15 different projects in Jira, but they use one common sprint. And all the projects come together on a single board. There is a program board where you can see all the projects, the stories from all the projects there, and you can filter by project. And it's all driven by one sprint. And of course, they have their separate boards as well, where they can manage their work independently. But then we have this program queue as well. We have common merge deadlines for the release. We have, cloud formation changes must come a little earlier because they are required to be consumed by the functionality that may be coming in that release. So we have intermediate deadlines for these types of changes that must come in during the release, and that is standard across all our teams in India, Cary, everywhere. So they all follow the same schedule. Yes.
Are all the QA and test defects cards in the same?
Yes, in the same system. Yes, all the QA test defects. We use one common system. Anybody can see a defect open anywhere. They can assign it across teams. It's the same tools that we use across the program for all that. Alignment to a common code delivery model. We saw the code delivery model that I showed you earlier with all the different branches. All the teams were master via a team stage stack. So every team has a staging stack. They should push their code first to that staging stack and build it there and show a successful build. And now we're also requiring them to pass certain tests that we call level 0 and level 1 tests in order to be able to merge into master. And this is to reduce the amount of breakages that we have in master. If we merge code in, when we have so many teams merging code into master, there's a high chance that something breaks in master. And it still does happen often for us. That is still an area of a challenge for us, and we are constantly trying methods and improvements to make that better. The release branch is cut at the end of the sprint, and then of course we have the same process for all the teams to spec fixes, have prior manager approval or prior director approval in later stages, and so on. That's all consistent and the same for all teams across the program. Alignment to a common process. So we have one release each sprint. There is a high-level release plan that is available about 6 weeks prior to the sprint start. And this is put out by product management. It is reviewed by it's put together by product management, but it's reviewed with our development directors, the test director, the UX management, and also the UI manager. So they are all in this meeting, and they review this plan. This is the high-level plan. Once they all reviewed, agreed, it's published then to the teams. And all the teams actually work off of that plan to plan the next set of stories into the upcoming sprint. The teams go through prior things. So the overall indicates the program level, and the team is at the team level, prioritizing the stories as per the high-level plan. And then the teams have pre-planning meetings, which happens typically about 1 week before the sprint planning meetings, which occurs typically about 1 week before the sprint starts. And the reason we have it 1 week before the sprint starts is that we, have published our set of stories to everybody. All the teams are now aware. If there are dependencies or last-minute tweaks and changes that need to be made, we still have a few days to do that before the sprint starts. Every team has their own internal end-of-sprint demo, and that is just to review all the work that was done within the team in that sprint. We do retrospectives, and at a program level, we have one end-of-sprint demo across the whole solution. It's actually done over, do it over 2 days, but it's 1 hour session each day. So it's like a 2-hour session, sometimes 2.5 hours. And it basically is showing the highlights from every team. So we have a very standard format, established format for this. Every team fills out a little time slot of the items that they are showing, and it's planned on basically the first and the second day of the new sprint as soon as the old sprint ends. We collect metrics and publish that, and that is at the program level. Alignment to a common process. Project managers collaborate with standardized practices. So we have one project manager in India, and the others are here. We meet on a regular basis. The practices are consistent. Ops is engaged throughout, and we have discussed the other things. The product managers are very engaged throughout our process. And dev and test work closely together again. So this has improved over the years of the collaboration between all these different groups.
Yes.
Yes.
Product owners come from business. Do they have to manage credit or do they?
No, they have to manage their data. They're functional. They have the functional view of it, of the features. Some key mindset shifts that we're working to enforce. So make the stories more granular. This is something that we're still still continuing to impress upon our teams. Break down the stories, make it chunk it smaller. March to master more frequently. It's much easier for us when we have 500 lines of code, new code, or whatever coming into master, let's say, every day, instead of 15,000 lines of code coming in at one time at the end of 30 weeks or something. Much greater merge conflicts and build issues and things like that when that happens. So we're trying to really impress upon our teams the need to break down stories, to deliver them early, and to send them into the pipeline earlier. Fix defects earlier in the pipeline. So it gets more and more expensive to fix defects as you go later in the pipeline. It requires more approvals, more people looking at it, more eyes. Much easier to find and fix defects earlier in the pipeline. Virtual services framework for testing. Again, this is something that we've come up with more recently that helps to simulate the data that may come from interfaces. If you don't have a functioning API yet that's under construction, or you have dependency on another team that needs to provide some data, but we can mock it and kind of try to, or simulate it sometimes by pinging the service and getting the data, just not through the interface that it would go through. We're on the last couple of slides. This is from the Scaled Agile Framework, and this is I thought a very important concept to get our heads around, and I've shared this with our teams, and I wanted to share it here as well. So this diagram, the first sections of this diagram shows some anti-patterns that we need to watch out against. Even though we have agile sprints, we have iterations, we may sometimes fall into this pattern where we build in one iteration and then test in the next iteration. We don't, for the most part, we don't have that in our program. We have a couple stories that may slip because they weren't completed, but in general, we are able to deliver more than 80% of what we have planned. The intra-iteration waterfall, this is something that we do need to still watch out against, and we keep educating our teams to go towards this model, being more cross-functional, having more cross-functional iterations. So this, in the intra-iteration waterfall, you may, again, develop that designs where you have to build something to a certain extent, before, and then you hand it off to test, instead of almost going lockstep, every step as you're getting done, you engage test, and every step of the way you're working together with them. I'll come to you.
So do you have feature-based teams or component-based? Mix.
A mix, yeah. I would say it's more component, but it's not necessarily one component per team. It's a mix. This slide depicts a little more how we get to that truly cross-functional iterations, right? Truly cross-functional. So here you have a story. As a user, I can log into the system, and that story, for example, could be chunked up in these ways. And this is again from the Scaled Agile Framework. Log in with correct credentials. As soon as you're done with that, you hand that off to testing, or you engage testing can test with that piece. You have error handling for incorrect credentials. That's the next thing, and that can be tested. And once each of these pieces are done, you can merge that into the pipeline, extend it into the pipeline. You can merge it into the master branch. You don't have to wait until the whole thing is built in order to hand it over to test and then product management, validation, and then send it into the So this is something that we're still kind of trying to get our teams around this mindset, to break it down more and more and merge it and to send it into the pipeline more often, because that is, studies have shown that it's a much more efficient process. Increases focus, allows, makes it a much more efficient process when you work in smaller. So that brings me to the end of my presentation. Yes?
Thank you. This is it's
Thank you.
given.
Mm-hmm.
You had on the slide 100% automation. You spoke to the slide and mentioned more automation. I'm not trying to catch you on a semantic issue. Trying to seek out your insights on the tension of a DevOps environment with pressure for as much test automation as possible, yet at the same time, we have a system, we have knowledge about the system. As our knowledge grows about the system, then we can automate.
Yes.
And sometimes we have to not necessarily be able to automate everything, or at least that's my
Absolutely, that is correct. And I don't know what the 100% is that you're referring to. We're certainly not at 100% automation, and I'm not saying we need 100% automation. I just said it's possible to automate most of your pipeline. We're certainly not there yet. And we can automate much of the pipeline other than the first part, which is the actual development of the software. It's possible. But to your point, definitely you have to make the call on where it makes sense to automate. You don't want to, for the testing part especially, you may not want to, you have to really evaluate where it makes sense, where it adds value, what kind of tests you want to build and automate, which is where you get the most bang for your buck. So if you automate the whole thing, theoretically it's possible, but it's also a lot of work. And is it required? Is that kind of what you're going towards?
That's very helpful.
Yeah, okay. Other questions? Yes?
Talk to your team trying to make up, I didn't see anything with Scrum Master. Kind of reading your Agile and Scrum practice to make sure that you're building on it.
So we have Scrums. Most of the teams do Scrums every day. Some of them do 3 times a week. And the Scrum Master is a sort of it can be either the project manager or the dev manager. In some teams, just by the nature of the work that they do, it makes more sense for the dev manager to take over that role, and because there'll be some very technical details that are discussed even in the Scrum. In some other teams, which are a little more functional, or you're looking at the Scrum board and it's pretty evident what teams are working on, there it might be the project manager. So it's a combination of those 2 roles generally. Yes.
What are your retrofitting patterns? Because in your earlier slide, you had all of your iterations overlapping. So how do you get that continuous feedback and really not just scale the process, but scale the culture among the teams?
Yes. We do have retrospectives. Generally, I think most of the teams are doing it once every 2 sprints. We were trying to do it every sprint, and then it seemed a lot. So we are doing it once every 2 sprints. And we collect the feedback, and sometimes we float that feedback up to the program level and to the director so that other teams can see it as well. And some of the feedback might be just applicable to that team. And we certainly take that feedback into consideration and try to address the key points. I mean, sometimes we'll have 20 things that come out of a retrospective, and it's impossible to make improvements in all of those in the very next sprint or even over time. So we try to pick the 3 or 4 most important items and address them.
Do you feel like it was very interesting to see?
You're welcome.
Do you feel like the culture among the team has also moved with it? Do you feel like they're bought into it and that they feel part of the process and that they can see that among that confident to have that feedback and to make improvements?
I think we certainly have the confidence to give feedback. I think many of our employees feel free. I think we have very good leadership. We don't have any hesitation in going even and talking to the division head, about an issue if we need to. So I don't think there's any hesitation on the team members' part. And to your question, are they bought in? It has taken time, and it has definitely taken time to fall into the process of the continuous release, which requires that you're on much of the time, right? And it's not like a long development cycle where you have everything picks up steam towards the end of the release. It's not like that. The next release is coming up right immediately. So we do have that mindset that people have had to adjust to. But I think the team has definitely shifted towards that culture, and it's required. And the more they shift, and we're also kind of getting their feedback on how we can make it better so that we don't have as much pressure. We're trying to come up with ways to eat that as well. All right, I think we have to wrap up. We're out of time. Thank you very much for your attention.